Although we don't usually associate automobiles with chemistry, a lot of chemistry takes place in a working car. The burning of gasoline to run the engine, for example, and chemical reactions in the battery to generate electricity. Also, there is a lot of chemistry involved with the working system of an airbag. According to Joseph S. Murola, airbags are not inflated from some compressed gas source but rather from the products of a chemical reaction.
Before talking about the mechanisms and inner workings of an airbag, we must explain some concepts. We classify the properties of matter into two types, physical and chemical. Matter displays its physical properties without changing its composition. Changes in matter in which composition does not change are physical changes. Changes in matter in which composition does change are chemical changes. Under these definitions, we find two very important laws, the law of conservation of matter and the law of conservation of energy. In these, it is stated that neither energy nor matter can be created or destroyed. It can only be transformed in the case of energy or transferred in the case of matter.
The ideal gas law describes the relationship among all four gas variables, pressure, volume, temperature, and amount in moles, and contains the simple gas laws within it. We can use the ideal gas law to find one of the four variables given the other three. We can use it to calculate the molar volume of an ideal gas, which is 22.4 liters at STP, and to calculate the density and molar mass of a gas. We divide chemical bonds into three general types: ionic bond, which occur between a metal and a nonmetal; covalent bonds, which occur between two nonmetals; and metallic bonds, which occur within metals. In an ionic bond, an electron transfers from the metal to the nonmetal, and the resultant ions attract each other by Coulombic forces. In a covalent bond, nonmetals share electrons that interact with the nuclei of both atoms via Coulombic forces, holding the atoms together. In a metallic bond, the atoms form a lattice within which each metal loses electrons to an electron C. The attraction of the positively charged metal ions to the electron C holds the metal together. In the Lewis model, chemical bonds form when an atom's transfer, ionic bonding, or share, covalent bonding, balance electrons to attain novel gas electron configurations.
There are two main types of solids, crystalline and amorphous. Amorphous solids have their molecules arranged in a disorderly manner, while crystalline solids are arranged in different structures. The latter can be further subdivided into molecular crystals, ionic crystals, non-bonding crystals, metallic crystals, and network covalent crystals, all depending on the types of particles and the bonds that form the basic structures. The heat involved in a chemical reaction occurring at constant pressure is the change in enthalpy for the reaction. Like the internal energy, enthalpy is a state function. Entropy is a measure of energy randomization or energy dispersal within a system. Gibbs free energy is a thermodynamic function that is proportional to the negative of the change in the entropy of the universe. A negative change in Gibbs free energy represents a spontaneous reaction, and a positive change in Gibbs free energy represents a non-spontaneous reaction.
When an airbag activates, the reactions carried out include 6 different compounds and 2 elemental molecules. The first is sodium azide, which decomposes into both of our elemental molecules, sodium metal and nitrogen gas, which is the gas that inflates the airbag and protects the driver from potential harm. The other compounds that react and get produced while the airbag activates are potassium nitrate, sodium oxide, potassium oxide, silicon dioxide, and an alkaline silicate glass that contains both sodium and potassium.
All of these substances have different toxicities and cause different harm levels to humans. Sodium azide, the main reactant, is highly harmful to humans, and it is as toxic as some alkali cyanides. Nitrogen gas, the one that inflates the airbag, is non-toxic to humans, and already makes up over 70% of our atmosphere, so it isn't dangerous for the environment either. Sodium metal, although not toxic to humans, is highly reactive and can easily explode and cause severe burns. Potassium nitrate can be toxic, but its highest dangers comes from its flammability and combustibility. Sodium oxide can be irritating to the throat and lungs and many other sensible parts of the human body, besides causing a burning sensation in the respiratory tract. Potassium oxide, like sodium oxide, is highly irritating to areas like the eyes and nose, but it is also more toxic and can be corrosive to the skin. Silicon dioxide is the main component of sand and quartz, and is only dangerous when inhaled in large amounts. The alkaline silicate glass can be toxic if ingested, but it's safe as long as one doesn't come in direct contact with it.
When a car's sensors detect a head-on collision, they send an electrical signal to the airbag modules within the steering wheel and the dashboard, which then activate the airbag mechanism. The airbag mechanism in itself contains three compounds: sodium oxide, potassium nitrate, and silicon dioxide. The electrical signal sent in the event of a crash heats up the sodium oxide to its decomposition temperature, at which point it will separate into nitrogen gas and sodium metal. The nitrogen gas generated from this reaction fills up the airbag, protecting the car's passengers. However, the sodium metal, a byproduct of that reaction, is highly unstable and is bound to react with any source of water, even air moisture, causing a dangerous explosion. This is where the potassium nitrate comes in. This compound reacts with the erratic sodium metal and creates sodium oxide and potassium oxide. These two, also being hazardous to human health and highly reactive, finally react with the silicate dioxide, creating a sodium-potassium silicate glass which is inert. After making this project, we could see the great importance that airbags have in saving human lives, because it is thanks to this mechanism that people do not hit their head with the car's glass or the steering wheel. And this wouldn't be possible without the chemical reactions exposed at the beginning of the video. Despite every good thing that they have, it's important to remember that we are working with dangerous reactants that could cause harm if you don't treat them correctly. Some of them can even cause death. Finally, we could notice that all these chemical reactions can damage the environment if we do not manage it with the right procedure. So it is important to dispose of them in special containers and in this way save people from car accidents and nature.